Greetings and welcome. Vectors in space is what we're talking about today. And we are on page 50 trace. That's right, my friends. Vectors in space, 50 trace. It says find an ordered triple. That's right. To represent u, or anyone really, in each equation if v is blah, w is blah, and z is blah. And notice they use their cool like little angled brackets. It's a little hard to see in this blurry picture here. So vector u is equal to half of vector v, so I'm going to multiply it by a scalar. So 4, -3, 5, right? Minus vector w, so that's going to opposite all of those values if I want to think about it that way, or just subtract them. It's up to you, whichever way you want to think about it. And then plus 2z, and z is 304 there. So this really just kind of behaves like distributively in some capacities. So this would become vector 2, -3 halves, and 5 halves. This would become, well, that's the same. I'll tell you what, I don't think this actually saves any time, but I feel cooler doing it. So, bam. I'll pretend I was efficient there. Plus, and then this vector would be 6, 0, and 8. Right? And now in order to do this, when you add or subtract vectors, you just kind of add or subtract their corresponding elements, or coordinates is probably the more appropriate term. So 2 minus 2 is 0, plus 6 is 6. -3 halves plus 6. Wait a minute. Guys, why did I get... Oh, 2 minus 2. That's what it was. Okay. So this 0 is not going to have an effect, so it's just -3 halves minus 6. So let's see, -3 halves minus 6 is minus 12 halves, so that's going to be what, -15 halves, if I'm not mistaken. 5 halves and plus 1, so that's 2 halves, so that's 7 halves. Plus 8 halves would be 16 halves, so 7 plus 8 is... Wait, 23? Wait, 7 plus 16, sorry. Yeah. Wait, now you're... Wait, what'd you say, 23? Now you're confused. I got lost already, guys. I'm scared. So 7 plus 16 is 23. I agree. Okay. Craziness. Halves there. Yeah, good stuff. So so that's written as kind of improper fractions. That would be my vector u, and that's the idea there. You could also write those as decimals or something if you wanted. So there's question 23. It's really just multiply by a scalar, which is distributive, and then to add or subtract vectors of any number of dimensions, really, you just add their corresponding coordinates. All right, write vector LB as the sum of unit vectors. So the first thing I'm going to do is let's just figure out LB and write it as an ordered triple. So to do that, I'm going to do 5 minus 2 is 3, -6 minus 2 is -8, and 2 minus 7 is -5. So when you do this, it's kind of like x2 minus x1 and y2 minus y1 and z2 minus z1. And that's what I would get. So there's the vector as an ordered triple. To write it as the sum of unit vectors, lagging out, my tablet shut off, kind of, then all I would do is merely add some ijk's to these. So I'd have, this is the same as 3 times vector I, which is the unit vector in the positive x direction, minus 8j, which is the unit vector in the positive y direction, minus 5k, which is the unit vector in the positive z direction. Well, it would, I could write plus a -8, but why not simplify it like so? So anyway, so thanks for watching, Internet friends. Have a great day. Bye-bye.